Hey guys, Dave Mazzetti here. Today I'm going to talk to you about an example application with TxtAI. If you haven't heard of TxtAI before, TxtAI is an all-in-one AI framework for semantic search, LLM orchestration, and language model workflows. Today in this application, I'm going to talk to you about something a little bit different. This is a baseball application using player data from the Layman baseball database. Recently, I had looked at GitHub Insights for the TxtAI repository and noticed that a lot of people were coming across this application. It was getting a lot of traction, so I figured I'd just kind of step through the app and go into more details about how it was built. So we'll get right into it. This application, as you see, you're showing baseball stats. It's going to show a section for player versus search. It's going to show bat in versus hit in. And in this case, I have it loaded with the career for David Ortiz. Each row is a player year. So if for a hitter, it's going to show batting average stats. For a pitcher, it's going to show pitching stats. It's specific to one particular year. So if a player had over the course of their career 10 years, there's going to be 10 entries in the database for them and so forth. If they had 1 year, there's 1 entry. It's going to show here the longevity of their career from 2000, in this case, to 2016. It tries to pick the peak or the best year of their career based on OBS plus, on base percentage plus slugging. And then that's normalized to 100 over the course of all the data. I know a lot of OBS plus calculations tend to be over the course of the season. In this case, it was done across the data so that players could be compared across seasons. You'll see this dotted line here that's showing the average OBS plus. So you'll see the seasons where the player was below, where the player was above, and then kind of peaks and valleys as they go along. So looking at David Ortiz, it's saying his best year was 2007, but he had some other good years, 2012, 2016, and maybe some down years. And from 2003 to 2007 was some really good years, and so on and so forth. So looking at the comparison, how do you compare different players? You have David Ortiz at the top row here. It's showing all sorts of stats, which are just numbers, and these are all available from the Layman baseball database. And then it's comparing them to other players. So you got Jason Giambi, you got Todd Hilton, you got Lance Berkman, you got Alex Rodriguez, you got Joey Votto, so on and so forth. This is across all of time for David Ortiz. You look at, let's see what is a player vector and what's being compared. You got the age at the time, so 32 versus 31. You got 75 versus 75, 230 versus 240. So you could see why Jason Giambi on this aspect is similar. 111 walks versus 109, 41 home runs versus 35, 122 versus 117. Similar amounts of hits and relatively similar batting average, though David Ortiz had a really good 331 batting average and relatively similar OBS plus, 131 versus 127. So it shows you what the rationale between considering these players to be similar, and these vectors are each one of these rows are pretty much a player vector. These numbers are loaded into TxtAI as in TxtAI's embeddings database. The TxtAI database normalizes all data, so that puts all of these elements into kind of the same realm. Obviously 149 and 331 are not going to be very similar. But when you normalize it, all these numbers will kind of come down into the same relative vector space. You could also limit things down to just a single season or to the last 5 seasons. In this case, we'll do the last season and just see similar players to David Ortiz from the last season that the Layman database has data, which is 2024. So David Ortiz, the most similar 2024 season for David Ortiz was Juan Soto. Then it's looking at Yordan Alvarez and Vlad Guerrero. And as you can see, there's similar height, similar weight, similar number of at-bats, similar number of home runs in the 30s and 40s, similar RBIs, and then similar OBS plus. Same can be done for pitching. If I switch over here, I could, just picks a default as you switch between. So I could go to any player, and there are some minimum stat requirements, like you had to have at least 350 at-bats or, a number of appearances pitching-wise just to keep things, as similar as possible, making the comparisons as fair as possible and similar as possible. So we're going to type in Greg Maddux, and I'm going to get rid of this one season filter. and we'll go back to that later. All right, so for Greg Maddux, I'm going to look for similar players to him, and then we're going to look at his season. So it's pulling up similar to the hidden side, except where this graph is by wins adjusted, which is a metric I'm just using that's trying to normalize starting pitchers and relief pitchers into one similarity. So it's looking at saves, it's looking at other things, and I'll look at the data, the code at the end, and we can step through that. But his average over the course of his career was a wins adjusted of 4, and then in this peak season it was 7, 8. So that was his best year. 19 win seasons, pretty good. 181 strikeouts, and you're looking at a lot of different things here. The walks hits per inning is only 0.81. And not a ton of 23 walks. I mean, over the course of a whole season, that's pretty impressive. 10 complete games, 28 games started, so more games started than walks. That's just really a really good season. So let's look at compared to other, and it goes way back. You got Slim Jones, you got Jason Schmidt, you got Walker Buehler, you got Zach Greinke. So modern players from a long time ago, 1934. We could look at just last season and see for the last season who were which is 2024. Keep in mind it's the last season that's available in this database. Let's see similar pitchers to him. So you got Zach Wheeler, which makes sense, 16-7. Pretty good batting average. Adjusted or batting average against, similar, decent, but not as good as Greg Maddux's good season, obviously. And then, you got Logan Gilbert, which when you look at this on the surface, you say, why would a pitcher who's 9-12 be in this list? But, he only had a batting average against of 196. Only gave up 37 walks. So, if you look at, walks innings pitched, only 0.95. So that's a pretty good year. I don't really know the details about behind. Actually, I look at the wrong low. It's 0.886. So even lower. So very close to Greg Maddux's 95 season. So pitcher can only control what they can control. They can't, control a lot of things, whether it's the team or bad luck, whatever it was. It was a really good season for a 9-12 season. So that's why it's in the same space as Greg Maddux. So let's step through. This is the application. Let's go step into the code of how this thing works. So we have a couple of helper classes that load these stats from the layman database, load the columns. These are all just abstract classes. There's one for batting, and there's one for pitching. So batting, you see all these columns that are here that are being calculated. You see where the data is coming from in the database, how these calculated columns that were derived are calculated, and how the vector is created. And then pitching, same kind of thing, but it's going to obviously have some different stats for, batting average against, and then, innings pitched and wild pitches, things like, shutouts. And that's going to then calculate these stats. And so it creates these vectors, which is all the same rows that you saw earlier. And then, looking at how this is indexed, each of these vectors are aggregated up into an array, and then each array, which is a single player year vector, is indexed in the database, and then it's becomes searchable through the search function. Someone enters in a query, it goes and tries to find the most similar player for that query, which is, it's going to have to go to the vectors because we have this whole stored player vectors array, and then we have to go find, if you look up David Ortiz, it needs to find the 2007 David Ortiz season, and then go find what the most similar vectors to that are. So that's how this application works. I know it's a little bit of a different approach to, let's go back and look at the app. A little bit of a different problem set. Most people look at TxtAI and say, all right, well, maybe it's focused on text. No, it's multimodal, as I said earlier. So it's multimodal. It can support all sorts of different types of information. If you can vectorize it, it can be loaded. This is a application maybe many wouldn't have thought of, where we're vectorizing a baseball player's year, but it could be a lot of different things. So it could be business stats. It could be, in other sports like soccer or football or hockey. If you have access to these stats, or you could modify this application and add in 2025 if you have that data available, and see what that adds into. So I'd be interested to see if this app is available. It's in the examples page. I'll put the link with it. Hopefully you found this interesting, and be interested to if you come up with derivative of this application, feel free to share with me. But I'm always interested to see if people are able to apply these examples to other problem sets. Have a great day.